Yes, yeah, so you can hear me. It's probably unlikely that I'll be able to pick up.
Hey!
I mean, you can probably hear that. But I'll try to repeat your question if it's, or at least what it is we're talking about when I'm doing it, so that when you watch the video, it'll be hopefully obvious about what it is that we're referencing here. So, Claudia, let's go ahead and start with you.
Can you go over max and minimum value?
Sure. So let's say that we have an example here. Let's say that it looks like maybe something like this. So this is weird looking, but I tried to pick something weird looking where I can deal with like all the possible cases. So some obvious max and min locations are like any top of a hill is a maximum. So I could say like this value and this value are maximums. Okay with that idea? And really, let's pretend that this piece up here is, I'm going to try to just get the red. Just give me the red. Ooh! I'm pretending that this piece is actually all flat there. So we have those. So let's say maybe this is the x value of like -3. And this is maybe starting at +3 and going to +4 or something. So I have maximums at x. So I have those, right? So that is going to be the set of x's such that x equals -3. And then also the interval from, -3 to, not -3, +3 to 4. Okay with that idea? Minimums would be like the bottom of a valley. We don't have any of those on this graph because I was dumb and didn't draw any in there. But I also have to worry about like half of the bottom of a valley. So we do have a couple of those. Right? You can imagine like this piece keeps on going or this piece keeps on going and you have half of, like that's half of the valley or whatever. Those guys also count. So let's imagine this is at -2 and this is at, say, +5. So our min then, -2 and +5. Yes. So this can't be a minimum because the like negative infinity is not a number, right? It's like a concept or whatever. So we can't have maximum and maximum minimums at like a negative or positive or negative infinity. If that makes any sense there. Okay. Claudia, does that feel any better about what we mean by a maximum or minimum? So if we wanted to talk about like a max value or minimum value, that would just be like the y-coordinate at those places. Okay? So the max and mins, these are x's, and the max and min values, those are y's. Is this about this question or this topic? Questions on this topic first. Lily. It's not a real number. That's just all like notation. All right. Bryce? Yeah, so for a bike question, I would give you like I would give you some data. so that everyone's working from the same data set. So maybe I'd have like a table that has like some observations. So maybe we have a bike with like 2 cranks and 3 axles or something, and maybe these are the wheel rev for 1 pedal rev. So maybe we have something like you observe something like this, and then let's see, what else did we observe in the lab? We counted the teeths, right? So maybe we had like a table here where we have like the teeth in here. Maybe we have something like this. And this would be a table for the gear ratios. So like I'd expect you to be able to calculate the gear ratios. How do you calculate these? Yeah, it's the crank divided by the axle, right? So this would be like, I don't know, like 1 point, that's 5/4, so 2/5. That would be like 5/3, like 1.6 repeating. And then this would be 2.5. This one would be like 1.3 repeating, 2, and then 3. Right? Everybody's okay with that idea? And then I would also have to give you like the wheel diameter. Let's maybe say like it's 27 inches or something. So in addition to asking you to be able to calculate gear ratios, I could ask you like how fast in pedal revs per minute to go, I don't know, like 35 miles per hour or something, or 10 miles per hour, it doesn't really matter. So you could do this in kind of 2 different ways. In the lab, in the bicycle lab, we implied that you'd want to find like how far you go for 1 pedal rev. And you can use that as a conversion factor and multiply it with the conversion of miles per hour to like inches per minute. And depending on how you set up those ratios, you can multiply them together to get the answer. The other alternative is you can do this in just one big long unit conversion that is really the same steps as this. It's just written out in one line. Inches per minute. Yeah. So if we wanted to do it in kind of one line, we can start with miles per hour, and we want to end in pedal revs per minute, right? So let's just first convert like hours to minutes. And then I'm going to need to work on converting miles to pedal revs. So I know 1 mile is 5,280 feet. And I know 1 foot is 12 inches. And I know that I have 27 pi inches in 1 wheel rev. And I know if I go back to my table up above, which table should I look at, the first one or the second one? The second one. And which number should I pick if I want to go in the most efficient way possible? 3, the biggest one. So I get 3 wheel revs for 1 pedal rev. And now if I multiply this all out, let's look at the units that are going to cancel. Miles cancel with miles, feet with feet, inches with inches, wheel rev with wheel rev. Hours with hours, so we're left in pedal revs per minute. So you're just going to multiply that all out, and you'll give an answer, and you can do that all in one line. That's acceptable also. That's the diameter of the circumference of the wheel. Because I told you up as one of the given things, we'd have a diameter of 27 inches or something. Okay with that? So again, the stuff in black would be things that I would give to you. The stuff in red would be stuff that, like you would have to do, well, I guess black up to here. Anything after there is stuff that you do yourself. But that's what I kind of mean by doing the bike calculations, if that makes any sense. What? Yeah, 3-wheel revs. And just as an aside here, was concerning the bike stuff, I would also expect that you could answer just kind of like general lab-related questions, like which one of these gears is the most efficient, or speeds is the most efficient, or like which table of data is more accurate, or like write the gear order from most efficient to least efficient, or something like this. I'd expect you to be able to do those kind of general understanding kind of questions as well, where if you've just paid attention to the lab and you understand like what the quantities are involved or what these numbers mean, you shouldn't have really any issue there. Claudia? Sure. So our definition for even is if f of negative x equals f of x. And our definition for odd is when f of negative x equals negative f of x. So there's two kind of ways you can do this. You can look at these algebraically, and we'll do that first. So maybe we have our f of x is x squared. So if I want to test whether this is even or odd, I'm just going to look at what happens with f of negative x. So when I do f of negative x, that means that I'm going to plug negative x in for x, right? And negative x squared is just positive x squared, because negative x times negative x is positive x. And this is f of x, right? That was what we started with originally. So what does this tell me? That's even. Okay. Let's now consider x cubed. So again, I'm going to start the same way. I'm going to look at negative f of negative x. That's negative x cubed, which is the same thing as negative x cubed. Right, like that. Which is, in fact, negative. If f of x is x cubed, this is negative of f of x. So what does that tell us? This is odd. And keep in mind that there is another option here. They don't have to be odd or even. They could be neither. So let's look at an example here where it's just x cubed plus x squared. So again, I'm going to start the same way. And we know what each of these gives us. And we can see clearly that this is not equal to f of x because of the negative sign here, right? And we see that this is not equal to negative f of x because that would be negative x cubed minus x squared. So that we would say this is neither. So up here we showed it was not even. Down here we observe it's not odd, so that this is neither. The other option for looking at this, Claudia, is you can look at this graphically. So when I talk about a function being even, what this essentially is saying graphically is a reflection across the y-axis does nothing. So, for example, if my function is, say, x squared, if I reflect this across the y-axis, the right side of the graph gets reflected and it lays right over the left side of the graph. And when I reflect the left side of the graph, that lies right on top of the right side of the graph. So we notice that there is no change, right? In that means we're even. Okay? If we have an odd function, this means that a reflection across the y-axis is the same as a reflection across the x-axis. So, for example, our graph of y equals x cubed looks like this. So we'll do the y-axis first. When I reflect this across the y-axis, the top half goes over to that side, and the bottom half goes over to this side. Okay there? So when I reflect across the x-axis, this piece goes down here, and this piece would go up here, and notice that they are exactly the same result. So that means that we're odd. Okay with that? So you can think about it either way, depending on what information you're given. Maybe it's more effective to think about it algebraically or more effective to think about it graphically. But that's basically what's going on. Does that make sense? Okay. Nathan?
Yes. Could you write an absolute value function on the board and just talk through what it is?
Oh, sure. Transformations of an absolute value function. Okay. Okay. So when we talk about transformations of an absolute value function, we are always referring to the parent function where it's just the absolute value. So my general form here with my a, b, h, and k is going to look like this. And I'm going to use that in my descriptors for a, b, h, and k to describe the transformation. So let's say, yes. And that's why we've had you memorize them, because they keep staying the same thing regardless of our function type. Yes, so this is the same chart of descriptors that we memorized for Module 1. Yep, so that should be, so let's say we have this absolute value function. So I would start by just identifying the value for a, b, h, and k. And the way I'm going to do that is I'm just going to use my general form up here. So my a value, well, that's -2. My b value, notice it's 1 over b here, so this number, I need to take the reciprocal. And then my h value, notice there's a negative sign in the formula, so when I look here, I want the opposite of it, the negative of it. And then my k value is here, so oops, I have -4. Okay so far? Okay, now I'm going to look at these values and use that list of descriptors that I memorized to write or describe the transformations. So for the a value, I need to look at two things, whether it's positive or negative. Since it's negative, what does this do? Yep, it's a reflection in the x-axis. And then I need to look at the magnitude of a. Since that magnitude is bigger than 1, we also have a vertical stretch. Then I'm going to look at the b value. The b value is positive, so that does nothing. If it was negative, we'd have the reflection across the y. I'm just writing that there because I often see students forget to check both parts there. So my b value is also, the magnitude of it is bigger than 1, so that tells me it's a, Yes. And then I'll check the h value. That's negative, so that means we go left 1. And the k value is negative, so we're going to go down and then 4 units.
I would pass that. Maybe the two-part question would do this, and then after you describe it, make the echelon table.
Sure. Yeah, I could absolutely cram a bunch of those bullet points together into one question with multiple parts. So we could certainly ask you to describe the transformation for this function. And then we could also graph it. Sure. So let's do that next. So if I'm going to graph this thing, I need how many points? 3. And what's the one point that has to be in there? The vertex, which is HK. Where does that need to go? In the middle. So in this case, my vertex is the point -1, -4, right? And now, my other x values in my table, I just need to pick an x that's less than -1. So maybe -2. Or an x that's bigger than -1, maybe 0. Everybody's okay there? And to find the y-coordinate, what do? Plug it in. So does it matter which one I plug in? No. Let's say I plug 0 in. So starting from the inside out, because we're just simplifying. And then 4 is the same thing as 12/3, or -4 is the same thing as -12/3, right? So that's -14/3. But if we're going to graph this, might as well make it a decimal. That's a 6. Everybody okay there? Oops. Put that in the wrong spot, though, huh? Because we did that for 0. Notice here that these are both 1 unit from the vertex when I picked them, right? So what does that tell me about this y value? It's the same. So then you can just plot that stuff. So it's like going to look like that or whatever. Questions about this graphing piece, Sierra?
Will you have like a film green thing for the area
No.
Okay.
I just going to trust that you have them memorized now. Bryce?
So that would be an example of making it properly formatted XY table and graph.
Correct, yeah. So we made our properly formatted XY table, and then here's the graph of our function. Obviously, I had to make tick marks and stuff here that I just neglected to do. But okay, so far? We also would ask you for the domain and range for something like this. I could certainly ask you to do that. So if we go back, the easiest way to do this is to look at our graph, right? So if I look at this graph over here, what's the domain going to be? Domain is about which coordinate? It's the x coordinate. So if I start with the smallest possible x's, do those correspond to points? Yep. So -infinity. And then every x in between, all the way out to positive infinity, is going to be a point, or correspond to a point on my function, right? The range is about which coordinate? The y. Good. So the smallest y value is down here at -infinity, right? And we go all the way up to which y value specifically? -4, right? Okay there? What if we wanted to be able to figure out the domain and range without graphing? And this is Again, really just talking about absolute value functions only. Well, the domain, that's easy. It's always all real numbers. So you just don't even have to think. The range, well, it depends on A. So if the A value is positive, we're going to do one thing. If the A value is negative, we'll do another thing. So if the A value is positive, the graph is going to open upwards, right? So it means we'd start at the K value and go up to positive infinity. If the A value is negative, it's going to open down. So that means we start at negative infinity and we go up to the K value. Now, could you have graphed the thing and to figure those out also? Sure, but that's like just a little shortcut to get around having to look at the graph. But if you're more comfortable looking at the graph, surely do that. If you're like, oh, that makes a whole bunch of sense, that's really easy to remember, I'll just do that, that's fine too. Claudia? Sure. So let's say that we have this thing, and it's a less than inequality. So we have abs val less than number. Okay with that, Riley? Sure. So the places that we're going to be concerned with is either the stuff here that's below the line, or maybe I'm going to be concerned with the parts of the absolute value that are above the line. Okay with that so far, Claudia? Okay. So since it's less than, so this is the absolute value under the line. If it was greater than, it would be the above part. Okay with that? So what I'm going to do is I'm just going to look at what these two x values are now and write that interval or that set of inequalities. So this, let's say, is 2, and let's say this is 10. Okay with that? So my answer is just going to be 2 less than x less than 10. Or I could write it as the interval 2, 10. Or I could say it's the set of x's such that 2 is less than x is less than 10. Any of these would be fine to write the solution set for. If this was, say, instead less than, if it was a greater than, we'd have two parts, right? We'd have x is less than 2 or x is greater than 10. Or if you wanted to write it as an interval, you do negative infinity to 2 union 10 to positive infinity. Right? You could write it that way. Or if you want to write it in a set notation, set of x's such that x is less than 2 or x is greater than 10. So any one of those notations is fine. Does that make sense to you there, Claudia? So if you're just looking at a picture, even if you don't know, like, per se, how to solve the equation or how to solve the inequality, you could just interpret it kind of this way from the picture and just talk about the places where the graph is either above the line or below the line. Okay with that? Bryce.
Could you explain how you know if an absolute value equation is either all real numbers and no solution?
Sure. So when we're talking about solving an absolute value inequality, if we have like absolute value less than negative, does that ever happen? No, absolute values are always greater than or equal to 0, so this has no solution always to it. If I have an absolute value that's greater than a negative, well, absolute values are always greater than or equal to 0, so clearly they're always going to be greater than or equal to a negative, so that would be all real numbers. So let's see if we can come up with a specific example here where one of these two things happens. Bear with me as I'm just trying to make this up off the fly. So if I have this, I subtract 6 from both sides. Absolute value greater than negative. This is all real numbers. That's my solution, right? Does that make sense there, Bryce?
So there was a way you would provide that after.
Right, yeah, you'd still do the same order of operations. So if this was like, if there was like a 5 here, you'd still do the divide by 5. But that doesn't really change much, right? Because we're still greater than or equal to a negative. So, again, regardless of what the solving is, when you get it down to just absolute value greater than a negative or less than a negative, automatically you can stop there because you know it's going to be one or the other. Okay with that? Okay. What now? Nathan? Sure. So linear function from story problem. Okay, so let's just come up with a little example here. So let's say Nathan has a cell phone. He pays $15 each month as an activation fee, and 8 cents per text. Write a linear function to describe his monthly bill. Okay, so kind of standard situation. So since this is a linear equation, we know it's going to look like y equals mx plus b, right? Okay, so let's figure out kind of what each of these numbers is kind of pertaining to. So this function, excuse me, I just frog in my throat. So this function, the y value is representing what in this situation? That's the dollars in the bill. And the dollars in the bill is going to depend on what quantity? Yeah, the number of texts. Right? So we want to be able to describe the monthly bill, so that's the output. And the input, the thing that it's going to depend on, is how many texts we send. Okay, so I know that the b value is the y-intercept, and that happens when the x-coordinate is 0, right? So if I send 0 texts, how much will my bill be? $15. Why 15? Yeah, the activation fee we're paying no matter what, right? If we have the cell phone, even if we don't send any texts, we're paying that sucker. Okay. So I know then the b is 0. Or, I'm sorry, the b is 15. Everybody happy with that? Okay. Now, we have one other quantity to figure out. We need to figure out m. So the m is the slope, which is a rate. Are we given a rate in this problem? Yeah, $8 per text. Guess what that is? That's your slope right there. So my function then is y equals 0.08x plus 15. Yes, Sierra?
How did you know he sent it? Like, how do you know he sent one text?
I didn't know how many texts he sent at all. I said, if he sent 0 texts, what would the bill be?
So how would you know how many? Yeah, but how would you know like how many things he sent?
You don't, but that's what the function is doing. It's allowing you to pick any number of texts and find out how much his bill is. So, after, stop talking please. After I did this, let's say I could ask you the question, Nathan's bill last month was $17. How many texts did he send? So we could ask you to do something like this. The 17, what is that giving us? That's a Y value. And how many texts did he send? What are we looking for? X. So it's just literally just solving this thing. I'm getting too many pages here. So 25 texts. Apparently Nathan doesn't have any friends. Woo! All right. If he had a better plan, maybe he'd be more willing to send texts. 8 cents per text is kind of expensive. Bryce, you got some questions? Sure. Let's say let's think. I'm trying to come up with something that's kind of realistic that isn't going to get too wordy. I can't think of anything good right now. Let's say a factory is making 10-inch boards. So, like wood. The quality control will accept boards within a 1/4 inch of 10 inches. What range of boards is, that's not how you spell is, acceptable? Okay. So when we say like within such and such amount like that, that's telling me that I could be 0.25 more or 0.25 less than 10 inches, right? So that's going to be the other side of an absolute value. Everybody's okay so far? And then, so this, if x is the board length, if I subtract 10 from it, the target length, it has to, the actual board length has to be within 0.25 of that goal length, right? So then I could just solve this. and yada, yada, yada. And to figure out what this label is here, if it's an and or an or, we would graph these things. So here's 9.75, here's 10.25, less than, greater than, so this should be and. The other way you could do this is you could write that as a compound inequality this way. This would be okay too. So if you're more familiar with writing them that way. Now probably most of us could read that story problem and be able to figure out the answer to it without actually solving anything, but on the quiz or the test or whatever, I will ask you to set up an absolute value inequality to model the situation and then solve it. So I am going to force you to, even though if you could solve it by just reading the thing, because it wasn't too difficult, you will have to write the equation too. Claudia? Yeah. A story problem with a greater than or equal to? Not for this situation. I mean, I guess you could, just by taking this as rejects, so you'd want to go the other way then. Is that okay with that, Claudia? So I guess if you wanted to turn it into a greater than story problem, the easiest way to change this situation would be to, instead of talking about, stop talking, guys, the things that were rejectable,